Hi, in this video I will discuss the role of genetics or heredity in obesity. Now, despite the fact that we're all exposed to the same obesogenic environment, not everybody is obese. Now, what factor can account for the huge disparities in BMI between ethnic groups and between individuals? A very likely candidate is heredity. There's strong evidence that obesity has a major hereditary component, which has been provided by what we call adoption studies, twin studies, and twin adoption studies. Now, adoption studies examine whether the BMI of an adoptee more closely resembles the BMI of the adoptive parents, which presumably have no genetic relation with the adoptee, or the BMI of the biological parents. Twin studies compare the similarity in obesity between two identical twins who are genetically nearly identical with the similarity in obesity between two non-identical twins. And finally, twin adoption studies, which were pioneered by Dr. Albert Stunkert, they compare the similarity in obesity between twins reared apart, which are thus exposed to a different environment, and twins reared together. Now, all these study approaches reveal that the influence of genetics on obesity is very large, whereas the environment in which a child is raised has surprisingly little impact. Now, more evidence for a major role of genetics in obesity came from overfeeding and underfeeding trials. Now, a classic study from Dr. Claude Bouchard from Canada found that when subjects were overfed a caloric surplus of 100,000 calories, the amount of weight gain was very different between subjects. Some subjects only gained 4 kilograms, whereas weight gain in others reached nearly 13 kilograms. Now, the most exciting finding was that weight gain was similar between two identical twin brothers, whereas weight gain was much more variable when comparing different twin pairs. So the within-twin similarity was particularly strong for changes in local fat storage and the amount of abdominal visceral fat. What it means is that genetics not only plays a major role in determining how much fat is stored upon overfeeding, but especially where the fat is stored. Now, the people that gained the most weight were very efficient at storing the surplus energy into body fat, basically turning all the excess energy into fat. Now, other individuals saw a large gap between what they should have gained based on the energy surplus, and then taking into account the energy content of 1 kilogram of body fat, and what they actually gained. And a very likely explanation is that the latter group also burned more energy as they overate, and their body weight increased, partly because their basal metabolic rate went up. Now, on top of that, even though these people were specifically asked not to increase their physical activity, it is also possible that people unintentionally become more active in the form of what we call NEAT, non-exercise activity thermogenesis. Now, Dr. James Levine defined NEAT as the energy expended in everything we do that's not sleeping, eating, or sports like exercise. It ranges from the energy expended walking to work, typing, performing yard work, undertaking agricultural tasks, and fidgeting. For example, you're watching this video, and some of you are sitting down, being very, very comfortable, not moving at all. Others are sitting down, but are a little bit restless, are moving around. And if you do that over the course of the entire day, that can consume a substantial amount of energy. And it seems that some people subconsciously increase their energy expenditure when they overeat, whereas other people don't. Now, underfeeding trials performed by Dr. Bouchard, in which people developed a large caloric deficit, similarly revealed that the between-twin variation in weight loss is much higher than the within-twin variation. Now, this important finding leads to the conclusion that the amount of weight loss is at least partly determined by genetics, and people that lost less weight compared to others may have compensated by being less active overall, thus by reducing their NEAT.